Our planet reveals its deepest secrets not in jagged mountains or winding rivers, but in perfect haunting circles etched into the earth like ancient runes. These circles, visible from space, aren't just geological curiosities. They offer a mesmerizing glimpse into Earth's turbulent past and cultural history, holding the keys to cataclysms, lost civilizations, and the very fabric of our existence. But is it just mere coincidence that so many gargantuan circular structures have found their home here, on planet Earth? Or is there perhaps something else that links them together, like a prodigious game of connect the dots? How can a collection of spherical scars and whispered legends just appear? I'm James Stewart, and you're watching Astrum Earth. For months, I've been scouring Google Earth to uncover the weirdest circular formations our planet, and in some cases our solar system, is capable of conjuring up. In this video, we'll unpack how the planet's most remarkable circular wonders came to be. We'll look at how collectively they tell a story of Earth's dynamic history. And we'll assess the possibility that certain circular formations, like underwater anomalies or patterns in remote regions, could be remnants of lost civilizations, or even linked to unexplained phenomena. These circles from space blur the line between myth and reality, so join us as we unravel their mysteries, beginning with a gigantic eye. In the early 1960s, humans had only just reached the final frontier, making it to outer space for the first time in 1961. In 1965, just a few years later, the crew of Gemini 4 departed Florida's Cape Kennedy Air Force Station on June the 3rd at 10:16 a.m. for a mission that would last 4 days, 1 hour, 56 minutes and 12 seconds. One of the main objectives for astronauts James McDivitt and Edward White was to complete the first American spacewalk, which they did successfully. But whilst James and Edward were floating around, tethered to their spacecraft by an 8-meter umbilical line, something was watching them. Something big and something ancient. There, in the heart of the vast, unforgiving Sahara Desert, appeared a colossal eye staring up at them from planet Earth. A weathered sentinel ever gazing into the abyss of space, only visible from up there. From a distance, one could argue that humans were never meant to reach. The Rishat structure, or the Eye of the Sahara, is a mesmerizing, nearly perfect circle spanning 40 kilometers in diameter. Its swirling rings carved by time itself. From space, it appeared as a massive spiral, a fingerprint of the planet's deep past, etched into the desert sands like an ancient mystery waiting to be unraveled. This geomorphological wonder is located in Mauritania, 200 kilometers northeast of the city of Attar, nearing the western border of the Great Sahara Desert. Although first discovered by French geologists in the 19th century, it can only be appreciated in its entirety from space. The images captured aboard Gemini 4 sparked a scientific frenzy, leading to numerous studies and expeditions in a race to uncover its secrets. In the years that followed, scientists and explorers alike were baffled by its eerie symmetry. Multiple theories sprung up from across the globe. Was it the scar of a cosmic impact, a gateway to a lost civilization, or something even more enigmatic? The Eye of the Sahara captured the imagination of people worldwide, inspiring countless theories and speculations about its origins and significance. Some have even suggested that the Rishat structure could be the remnants of the legendary lost city of Atlantis. Even today, there are those that still argue it's one of the above, but subsequent studies proved the geologic curiosity had a more complex origin, involving terrestrial processes. Before the first space images, geologists studying aerial photos suspected they were dealing with a meteorite impact site due to its nearly perfect circular shape, raised outer perimeter and sunken centre. It wouldn't be for several decades later that the truth was finally uncovered. Further geological research disproved the cosmic impact theory. There just wasn't enough evidence of melted rock at the site, which would normally be present after such an event. That's according to Michel Gebrac, a professor at the University of Quebec in Montreal, who specialises in mineral resources and who's done multiple studies on the Reshat. Thanks to modern geological research, including satellite imagery provided by organisations like the NASA Earth Observatory, scientists now know it to be an uplifted geologic dome, characterised by layers of sedimentary rocks that have been exposed over millions of years by wind and water erosion. To uncover its origin, we have to journey back nearly 200 million years as the supercontinent Pangaea slowly begins to break apart. Whilst North America had long ago separated from the original Pangaea, West and parts of Central Africa still remained, connected to eastern South America. Finally, these continents began to drift apart, alongside a major rifting event in Western Africa, known as the Cameroon Line. As the crust tore apart over the next 15 million years, large faults and points of weakness began to form, allowing the hot mantle from below to escape upwards and fill in the gaps left by these huge intrusions. One of these intrusions occurred underneath what is now known as the Eye of the Sahara, dating back over 100 million years in the Cretaceous period. The carbonatite that resulted was thrust upwards towards the surface, reaching shallow depths of around 1 kilometre. This massive body of molten rock pushed up hundreds of tons of more rock to form a dome-like shape. The formation's concentric rings are primarily composed of sedimentary rocks, including sandstone and limestone. The outer ring of the structure is composed of harder, more resistant rock layers, while the innermost depressions consist of softer rock layers that have eroded more rapidly over time. The Eye of the Sahara features an underlying alkaline igneous complex, including igneous rocks called gabbroic rocks, which form as a result of magmatic activity and hydrothermal alteration. That's a fancy way of saying that the Earth's material became so hot it turned into magma or liquid rock, and then forced itself into the surrounding rocks, slowly cooling into a crystalline structure. Erosion, both by wind and water, has also helped to sculpt the Reshat structure into its present form, exposing different rock types and creating its concentric layers and circular shape. Differential erosion rates between these softer and more resistant layers have further contributed to the striking appearance of the formation today, known as cuestas. As if that geological journey across millennia wasn't exciting enough, it may not be just rocks that work within this beauty. Some archaeologists suggest there is evidence that the Reshat structure was inhabited by early humans. Archaeological research has revealed evidence of human activity, with numerous deposits of pre-Acheulean and Acheulean artifacts, characterised by the distinctive oval and pear-shaped hand axes, normally associated with Homo erectus and derived species such as Homo heidelbergensis. What then of Atlantis? Humans once inhabited this structure. Does that mean there's something more to uncover? The legend of Atlantis, a mythical lost city or island, has captured the imagination of people for centuries. The earliest known written account of Atlantis comes from the ancient Greek philosopher Plato in and around 360 BCE. According to Plato, Atlantis was a large island located beyond the Pillars of Hercules, the modern-day Strait of Gibraltar, in the Atlantic Ocean. He described Atlantis as a powerful and advanced civilization that existed approximately 9,000 years before his time. The island was said to be ruled by a confederation of kings and was rich in natural resources, with a thriving economy and a strong military. Plato's account of Atlantis includes detailed descriptions of its geography. It was supposedly located on a central hill, with concentric rings of walls and canals radiating outward. That does sound familiar, doesn't it? Rings of alternating heights, walls, and water. You can see why there are droves of articles, documentaries, and videos suggesting that we may have finally found this mythical city here with the Eye of the Sahara. Indeed, it does match Plato's visual description, and you can forgive the tenuous links, perhaps more in hope than expectation. Could the Eye of the Sahara actually be the doorway hidden in plain sight to this lost city? I really don't think so. The existence of Atlantis has never been proven, and most scholars consider it to be a work of fiction or a metaphorical tale. Indeed, both archaeological and geological evidence have this one pretty well sewn up, but I did enjoy the story. Miraculously, this isn't the only giant eye staring back at us from space on this list, and the next one does something even weirder. But before that, we journey toward Johannesburg for the largest and oldest crater on planet Earth. Around 2 billion years ago, an asteroid hurtled toward Earth, crashing into the planet in an area near present-day Johannesburg in South Africa. It formed what is today the biggest and oldest known crater on the planet. Up until recently, scientists had widely accepted that the impact structure known as the Vredefort Crater was formed by an object around 15 kilometers in diameter that was traveling at a velocity of 15 kilometers per second. But here's the interesting part. The world's largest crater is actually bigger than we first thought. Over the course of 2 billion years, the Vredefort Crater has eroded. This makes it difficult for scientists to directly estimate the size of the crater at the time of the original impact, and therefore the size and velocity of the impactor that formed the crater. An object that is 15 kilometers in size and traveling at a velocity of 15 kilometers per second would produce a crater around 172 kilometers in diameter. However, this is much smaller than current estimates for the Vredefort Crater. Almost immediately after impact, the crater widened and shallowed as the rock below started to rebound and the walls collapsed. This means instead the structure's original diameter would have been between a colossal 250 and 280 kilometers during the time of the impact. Something able to create that much carnage would have to be much larger than first thought, 25 kilometers larger, and travelling at a velocity of 20 to 25 kilometers per second to explain a crater 250 kilometers in size. The centre of the impact was so strong that a 25 kilometer section of Earth's crust was turned on its head. The various layers of upturned rock eroded at different rates and produced the concentric pattern still visible today. You'll notice that only part of the ring is visible. That's because areas to the south have been paved over by rock formations that are less than 300 million years old. The young rock formations have begotten fertile soils that are intensely cultivated. The darker ring in the centre of this image, known as the Vredefort Mountainland, has shallow soils with steep terrain not suitable for farming, so this area remains naturally forested. Along the ridges in the mountainland, you can see white lines. These are the hardest layers of rock, such as quartzite, which resist erosion. The outer part of mountainland has exposed rocks that are roughly 2.8 billion years old. The impactor that formed the Vredefort Crater would have been larger than the asteroid that killed off the dinosaurs 66 million years ago, forming the Chicxulub crater. If the Vredefort Crater was even larger and the impact more energetic than that which formed the Chicxulub crater, its force may have caused even more catastrophic global consequences. More recent impacts like the Chicxulub event were followed by devastating fallout. Chicxulub caused mega tsunamis, violent earthquakes, firestorms that turned forests to ash, and atmospheric dust accumulations that caused global temperatures to drop for a sustained period of time. And of course, the extinction of the dinosaurs, which we'll come on to later. But Earth was much different when the Vredefort impact event occurred. There were no animals and no forests. Earth was much different during that time 2 billion years ago. There was only simple life. Oxygen was starting to accumulate in the atmosphere, and eukaryotes were only just starting to appear. Some circles from space are just simply beautiful to look at, but others, like this one, are forever stitched into the fabric of every single fibre of our planet's very existence. They're like deep battle scars that serve as a constant reminder of just how powerful external forces can be. As our circular journey around the world begins to take shape, it's time to meet a circle unlike any other on the list. There are some stunning examples of how Earth's geology and indeed things hurtling toward Earth have shaped these circles. But what shaped this next one is neither. The Mount Taranaki legend, a core part of Maori tradition, tells of a battle for the love of a mountain named Fahinga, where Taranaki, initially residing near Turangi, was defeated by Tongariro and fled west, carving out the Wanganui River on his journey. So key to New Zealand's story is this place. The mountain has been granted legal personhood, meaning it now has the same legal rights, powers, duties, responsibilities, and liabilities as a person, something that only happened this year in 2025. Person or not, it is perhaps one of the most bizarre looking circles visible from space on planet Earth. And for one very good reason. Us. Before humans arrived in New Zealand some 700 years ago, much of the landscape was heavily forested, a biodiversity sanctuary. In the 1800s, European settlers arrived in New Zealand, clearing those lush forests away on an industrial scale, making way for pasture land. Around 50% of New Zealand was eventually cultivated into grassland for animals to graze upon, and gone were its dense forests. But one area remained forested. The government reserved an area around the peak of Mount Taranaki to help defend against flooding and coastal erosion, and in 1900 it became a national park. Egmont National Park was defined as a circle, 10 kilometres in radius from the summit of the mountain, everything else cleared up to its boundary. The result was the perfect circle making up the base of the mountain, its luscious green forests standing out from space against the exposed grasslands in one of Earth's most symmetrical landmarks, quite literally drawn with a compass. Not only is the circle perfect, but the volcano itself is one of the most symmetrical in the world. It would win any geological beauty pageant. At 2,518 metres high, Mount Taranaki is the highest volcano on New Zealand's mainland, formed 135,000 years ago by subduction of the Pacific Plate below the Australian Plate. It is a stratovolcano, a conical volcano consisting of layers of pumice, lava, ash and tephra. Mount Taranaki is made up of an igneous rock called andesite, a fine-grained volcanic rock. These stratovolcanoes have steep sides, and look how volcanoes are usually drawn, giving it that perfectly symmetrical shape. Mount Taranaki is famous for its lahars, an erosional force that helps give it that distinctive shape. Lahars are where the glacier on the mountaintop is melted and the water rushes down the mountain slope, forming steep gullies on its way to the sea. Unlike any other circle in this video, this one could erupt. The last major eruption was in 1655, but more minor eruptions occurred in the 1850s. Ironically, what this means from a volcanology perspective is that an eruption is overdue, and may well destroy the very circle that produced it in the first place. Now, I warned you at the start of the video that there was another eye staring back at us from space. Well, not only is this one literally named after an eye, it's also capable of moving like our very own eyes. In the northeast of Argentina, in the delta of the swampy wetlands of the Parana River, there is a strange floating island nestled in the murky waters. Such a perfectly round oculus is El Ojo that legend has it UFOs are harboured deep below its surface. It is, after all, the perfect shaped garage for an alien craft. Strangely, that's not even the creepiest thing about this circle, because this circle moves. Unlike any other circle in this video, El Ojo is so peculiar that it rotates on its axis in a clockwise direction. This can be easily observed with satellite images from above. El Ojo looks noticeably different over time. Want more creepiness? Well, El Ojo translated to English means the eye. So when you see this circle from space, not only do you see an eye staring back at you, you see a moving eye blinking back at you. Another theory suggests that El Ojo is a gateway to another dimension or a supernatural realm. This idea is based on its movement, which some claim is not entirely explainable by natural forces alone. We shall see. Some even say people who get too close experience unusual sensations or time distortions. Well, fortunately for us, people have gotten pretty close to El Ojo and returned to tell the tale, actually fairly recently. And if UFOs, portals and time distortions weren't Hollywood enough for you, this circle was actually discovered by a filmmaker. Argentine filmmaker Sergio Newspiller, looking for a location for a paranormal film, came across the unusual formation while browsing Google Earth satellite images in 2016. His attention was caught by the unusual, almost perfectly round shape of the island, located in a hard-to-reach area of the Parana Delta. Newspiller told the newspaper El Observador at the time in a translated article. El Ojo, as he named it, is a disc-shaped island. 188 meters in diameter, covered in vegetation that floats in a crystal clear lake that is just as perfectly circular as the island itself. The island has solid, stable ground, a rarity in the Parana Delta, where soft, swampy terrain dominates. What's more, the surrounding water is exceptionally clear and cold, which contrasts from the region's typically warm and turbid reservoirs. Newspiller has so far taken credit for discovering this particular circle, but the likelihood is locals would have been aware of it for quite a bit longer. Either way, this is the youngest circle on our list by a number of centuries, but how did it get there? How is it possible to turn up one day to see El Ojo and then a few days later, it's in a completely different position? Because of its infancy, the origin of El Ojo still remains a matter of speculation, which is pretty exciting. Perhaps the most plausible explanation is that scientists believe the island and its lake formed through a combination of erosion and water currents. Over time, the rotation caused by circular water flow has gradually shaped the island and the lake into their near-perfect forms. This is a kind of rotational scaling, where the edges rub together and thus form its circular shape. This natural process resembles similar phenomena observed elsewhere, such as the ice discs in Maine's Presumpscot River. However, the exact timeline of its creation is still unclear. In 2016, Newspiller and hydraulic engineer Riccardo Petroni started crowdfunding an expedition to the island, hoping to perform scuba diving, drone data collection, and soil and plant analysis. However, their fundraising attempts failed, reaching only $9,698 of their $50,000 goal. On the 10th of October 2016, Kickstarter eventually declared the fundraising campaign unsuccessful. Perhaps if this video does quite well, we could finish that off and finally get some answers. We move on to perhaps the most deadly of all the circles visible from space. A circle that quite literally changed the entire course of planet Earth for eternity. We now know the origin of the asteroid that wiped out the dinosaurs and ended the Mesozoic era. 66 million years ago, an asteroid about 10 kilometers wide came rushing out of space at a velocity of more than 25 kilometers per second, striking what is now Mexico's Yucatan Peninsula. The enormous amount of energy generated by this impact, equivalent to 10,000 times the world's nuclear arsenal or 10 billion Hiroshima bombs, ejected into the atmosphere huge quantities of dust particles and gases. The asteroid penetrated the Earth's crust down to a depth of several kilometers. It vaporized, melted and shattered ocean water, and the Yucatan target rocks composed of carbonate and sulfate. The rocks underwent fluidization and started behaving like a liquid upon impact. What was left was a crater some 200 kilometers in diameter, the Chicxulub Crater. Over a short period of time, just a few minutes, several 100 billion tons of carbon dioxide, sulfur dioxide, and water vapor released by the vaporized target rock were injected into the Earth's atmosphere. An abrupt and global perturbation of the Earth system followed. The climate became unstable, the fine dust suspended in the atmosphere blocked sunlight, decreasing or even stopping photosynthesis. The collision and its aftermath ultimately killed off 75% of all life on Earth, including the dinosaurs. But what could possibly cause such a catastrophic event? The first clues that an asteroid was responsible for the end of the dinosaurs weren't discovered until the 1970s. Father-son team Louis and Walter Alvarez found high levels of something very unusual in rocks that dated back to the time of the Cretaceous, a geological period that began 145 million years ago and ended 66 million years ago. They found iridium. Now, iridium is quite rare on Earth's rocks, but rather common in asteroids, spearheading the theory that the impact had originated from space. At the time, it was quite a controversial take, however, and wasn't fully supported until geophysicists Antonio Camargo Zanugra and Glenn Penfield came along. They were exploring the potential oil reserves of Yucatan for the Mexican oil company Pemex and discovered the Chicxulub crater itself. In the early 90s, studies of the recovered core samples confirmed that the Chicxulub structure was indeed a huge impact crater. The force of the impact was so great that it altered the physical shape of the planet, transforming rock into glass-like spherules. These spherules were scattered across the world, where they are often found together with the distinctive layer of iridium from the asteroid. But even up until last year, 2024, something still stumped scientists. Where did this asteroid actually come from? I mean, obviously from space, but where exactly? It was suggested in the mid-2000s that it might have originated among the Baptistina asteroids in the main asteroid belt, but recent evidence has ruled this out. So instead, scientists turned to the chemical record this asteroid left behind, and what they found finally answered a 60-million-year-old riddle. They needed to determine what type of asteroid the Chicxulub space rock was, so the team took samples from rocks in Spain, Italy and Denmark, dated to the end of the Cretaceous. The data revealed this was no ordinary asteroid. Comparison between the chemical record left behind by the strike 66 million years ago and known meteorite samples suggests it was a carbonaceous chondrite, one of the oldest known types of asteroids, having formed billions of years ago in the early solar system. These chondrites can only stem from asteroids found beyond Jupiter, which is where our asteroid must have come from. Today, things look a little different, thankfully. The Chicxulub crater, which now lies partially on land, is the best preserved large impact crater on Earth. In the millions of years since the impact, the crater has been buried in thick layers of limestone. However, remnants of the crater are still visible at the surface. A 250-kilometre long arc of sinkholes marks the crater rim. Because rainwater is slightly acidic, surface water dissolves and seeps down through the limestone bedrock, creating solution pits, cenotes, and caves, as well as the world's longest underground river. When those thick layers of limestone erode, the chalky sediments wash out onto the broad, shallow Yucatan shelf. Oof, that was a lot, wasn't it? I don't know about you, but I could do with a bit of cooling off. We're going somewhere we haven't yet been in this video, down into the ocean. The Great Blue Hole in Belize, nothing but a deep blue void extending down 125 metres into the abyss. Near perfect circle some 300 metres wide. Whilst this might be one of the more familiar on my list, it holds the secrets to a civilization that thrived in these parts over 1,000 years ago. There is much more to the Great Blue Hole than just outstanding marine life. Let's start with how this got there in the first place, and that journey isn't as far back as the Dinosaur Killer we've just visited. We're heading back to the most recent glacial period, which occurred between about 120,000 and 11,500 years ago. At that time, the sea level was much lower than it is today, exposing the limestone bedrock of the region. Belize, particularly the Cayo area, is renowned for its extensive network of limestone caves, which to this day remain as uncanny reminders of a turbulent geological past. Over thousands of years, stalactites and stalagmites formed inside these caves. Rainwater rich in carbon dioxide slowly eroded the limestone, creating an extensive network of underground caves. As the Ice Age began to draw to a close, more and more sea ice entered the oceans, causing sea levels to rise substantially by more than 100 metres. Over time, that limestone cave system, a once dry cave network, was gradually flooded as the sea level rose, causing the roof to collapse and creating the circular sinkhole that we see today. One of the most notable features of the blue hole is its deep blue colour, which is caused by the depth of the sinkhole and the lack of sunlight penetrating its depths. Could life exist down here at all? In the winter of 2018, a submarine crew ventured to the bottom of the hole in order to create a 3D map of the sinkhole, confirming the gruesome truth about the Great Blue Hole's formation. Down at depths of 400 feet, near the very bottom of the hole, they discovered new stalactites that were formed when the sea level was about 500 feet lower. These had never been seen, let alone mapped before. Suddenly, the labyrinth below came to life. They also made some startling marine discoveries, deeming an area of the hole the conch graveyard. After observing hundreds of dead conches or mollusks that had seemingly fallen into the hole, couldn't get back out, and eventually ran out of oxygen and sadly died. They found tiny tracks where the conches had tried to backtrack up the hill, and tiny slide marks where they seemingly slid back down. But animals weren't the only victims of this deep blue graveyard. Marks where divers had tried to escape were also spotted, resembling something from a watery horror film, with old scientific equipment and even a GoPro discovered. Things got more gruesome still when they found the owners of that equipment, the bodies of 2 divers who had tragically also been lost to the hole. How many more people have died in this deadly abyss is still unknown. Strangely though, it's not what's going on below the surface that's most intriguing to me. The Great Blue Hole also provides a vital clue to a lost world. The Mayans were a once thriving civilization, reaching their peak during the Classic period, roughly from 250 to 900 AD. A time when they built great cities like Tikal, Palenque and Copan. During this time, agriculture flourished. But the decline and eventual collapse of this once great civilization has caused debate and confusion amongst historians for decades. And bizarrely, this geological wonder, the Great Blue Hole, offers a huge clue as to what happened. Professor Andre Droxler of Houston's Rice University led a team that analysed sediment from the Great Blue Hole. He found that the sediment indicated 2 long periods of little or no rain. The second drought apparently occurred between 1000 and 1100 AD, the same time that the Mayan city of Chichen Itza fell. They found that the ratio of titanium to aluminium changed in the 9th and 10th centuries, a period when the Mayan civilization in the Yucatan Peninsula went into decline. More titanium means that heavier rains were affecting the region, since the runoff from the area's volcanic rock is rich in the element. But from about AD 800 to 1000, the ratio between the 2 elements was much smaller, indicating that there was much less rainfall. In other words, a prolonged drought likely led to the collapse of classic Mayan civilization. On the complete other side of the spectrum, and as recently as April 2025, sediment core data extracted from the Great Blue Hole by geoscientist Dominic Schmidt let us into another meteorological secret. After studying a 30-metre sediment core extracted from the floor of the sinkhole, scientists discovered that tropical cyclones have increased in frequency over the last 5,700 years. In that time span, the researchers identified 694 event layers that they attributed to tropical cyclones. With this data, they were able to piece together how cyclone frequency has changed over time. The core revealed a steady trend of increasing cyclone activity over the last 5,700 years, with a key factor being the southward shift of the equatorial low pressure zone, known as the Intertropical Convergence Zone. This zone influences the location of major storm formation areas in the Atlantic and determines how tropical storms and hurricanes move and where they make landfall in the Caribbean. Based on these trends, we could be facing an unprecedented spike in tropical cyclone activity. There were 9 cyclone events in the last 20 years alone, a frequency that is inconsistent with normal natural climate fluctuations. So quite fittingly, our tour of circles from space comes full circle. It sounds like such a simple concept, doesn't it? To be honest with you, I was hoping in this video that we'd find some sort of wild, crazy missing component that somehow links all these amazing circles together. But actually, I think we've uncovered something better. On the surface, these circles just look like cool images that many wouldn't think twice about. But in reality, each one is a gigantic clue into the very fabric of our planet, shining a light on Earth's geological and even cultural history. So often, it's not just the circles themselves that are impressive, but also the reasons why those circles exist in the first place. Rather like soldiers' battle scars telling the story of a great war, these circular scars tell the stories of millennia or even eons. And so really that's what links them together. Collectively, they tell the story of a planet. Our planet. I'd love to have included more and more circles, but please do let us know in the comments if there's any circles that we missed or that deserve to have been featured here, and we'll see you in the next one. If your learning hasn't quite come full circle and there's a few things you want to delve back into, then I have good news. We partnered once again with our friends at Brilliant, who can help you become a better thinker and problem solver, with thousands of visual interactive lessons in maths, science, programming, data analysis, and AI. Whilst I love science, maths has always been a weak point of mine, and it's a subject I always conveniently manage to avoid, especially when I should be doing my taxes. That's what's great about Brilliant. I can learn a little every day on my own schedule, and it keeps me on track to reaching my learning goals, one day at a time. I've been doing the solving algebra course and getting back to basics, and it's so much more hands-on than reading a textbook like I did 1,000 years ago. Do I admit it's actually making maths fun? Do I say that out loud? Do I? To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/AstrumEarth. Scan the QR code on screen, or you can click the link in the video description. You'll also get 20% off an annual premium subscription. Thanks to Brilliant for sponsoring this video. Okay, fine, I'll say it. Maths is fun.